Okay, the second half of lesson 80 deals with polynomials. We're going to be identifying the number of terms that are within a polynomial. We're also going to identify the degree, and then we're also going to do a little bit of simplifying and rearranging these terms. So, first thing I would tell you is don't get too caught up in the term polynomials. It looks a little intense, but again, we're just going to focus on some basic principles and basic fundamentals of these. If we want to start by identifying polynomials, we want to look at the terms that they have. If we say that a polynomial has one term, that is classified as being a monomial. And recall, a term is just a number with a variable right next to each other. Okay? So an example of a monomial would be 7x or negative 4xy. Notice there are no plus and minus signs to separate these terms. If we say we have two terms, that is called a binomial. An example of a binomial is x plus 7. Notice that we have two terms there, the x as well as the 7. Or 2x plus 3y. Again, we have two terms. We have the 2x and we have the 3y. If we have three terms in a polynomial, that is considered to be a trinomial, which a trinomial could be x squared plus 3x plus 4. It could also be 2x minus 4y minus 5. Notice none of those terms are the same term, therefore they have to be left alone as the three terms written there. If we want to identify the degree, that all comes down to looking at the exponent, and it's the highest exponent within a polynomial. Therefore, if I have x to the fourth plus 3x squared plus 4x plus 11, I would say that the degree of that polynomial is going to be 4. And again, where does the 4 come from? Well, 4 is my highest exponent that I have there. If we look at negative 7x plus 2x cubed plus 4, I have three terms there, so it's a trinomial. But I also notice that my highest exponent is a 3, therefore the degree is again 3. So for example number 4, we're going to first identify whether it's a monomial, binomial, or trinomial, and then we're going to identify the degree. So let's start with identifying the monomial, binomial, trinomial part of it. So we ask ourselves, how many terms do I have here for part A? Well, I have three terms, 1, 2, and 3, hence trinomial. And now if we want to go ahead and identify the degree, we ask ourselves, well, what's the highest exponent that we have? Well, it's 3. So this would be a trinomial with a degree of 3. Next, we have 2x to the fourth minus 4. Again, our three choices are monomial, binomial, and trinomial. It has two terms, therefore it is a binomial. And also the degree, highest exponent is 4. So this is a binomial with a degree of 4. If we look at C, how many terms do we have? Well, we have 3 of them, 1, 2, and 3, so it is a trinomial. And if we identify the highest exponent that we have here, understand that this x is understood to be a 1, this y is understood to be a 1. So both exponents are 1, which means we have a degree of 1. Whether you're looking at the x or the y, it does not matter. Degree is 1. The other thing they're going to ask you to do in this lesson is to arrange the terms of the polynomial in descending order, which means we want to start with our highest degree, or our highest exponent, and list them in order down to our least exponent. So if we look at our polynomial here, we have 4 terms. We have 1, 2, 3, and 4. And now we want to rearrange these so that they're in order, starting with the highest one. Well, I notice that the highest one is this plus 2x to the third. So that one's going to go first. The next biggest one, the next highest degree, the next highest exponent is that plus x squared. The next highest exponent is this x out at the very beginning, the plus x. And lastly, we have that plus 2. It does not have a variable next to it. That's called a constant term, but that's going to go at the very end. And the last thing we can do here is we can add binomials. We can add these two expressions together. So it says to add the binomials x plus 6 and 2x minus 3. So here's my first expression, and we're going to add it with the next one. And if we look inside the parentheses, notice we can't add or collect any of these together. You know, the x is separate from the 6 and the 2x is separate from the minus 3. So essentially our parentheses go away. And what this turns into is our old-fashioned simplifying, or collecting like terms. If I start with the first one, the x, that matches with the plus 2. We keep our exponents the same. 1 plus 2 will get us 3. Lastly, we look at the 6 as well as the minus 3. So 6 minus 3 will get us 3. There's our expression. Practice problems that we need to work on are G, H, I, J, and K.